There we go. Hello, everyone.
Hello.
Hi.
What the heck? I think the Zoom has these new colorful little thingies going on the side.
I got half of you in color and half not, which is my problem, I think.
They look like little app buttons. Anyway. Oh, wait. Don't need that.
Hi.
Close that. Morning. Okay. Hmm. 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 Well, I'll just give it another minute or so, see who turns up. Two or three more, I think.
That way.
Yeah. Hello.
Hello.
Your screen's doing that again, Nina.
Oh,
Yeah. What is that about?
oh,
Camera misbehaving.
I don't know.
Huh.
It doesn't seem to help to go back and back in. So if I turn it off, and on, maybe it needs to rest for a minute. Reboot. Nina, reboot. I love computers. Oh,
So,
Still doing it.
how much does a set of headphones with a microphone run anyway?
not very much.
How do you think the microphone's related to it?
Oh, was I wearing them the other day, Nikki? Maybe that was it. I could try it without.
Can't
Huh.
remember if you had them on or not.
Here, let me.
I don't think so.
There. Oh, no.
Yeah, it's related.
Didn't help.
Very sporadic.
Can I distract us, Richard, with the question about last week?
You bet.
Did I hear you say that there has not been a culture that did not develop some sort of religion?
Yes, that's the kind of general anthropological view.
Never been a group of people that lived together without developing some sort of belief in what do you say? Belief in another being, belief in something other than themselves.
Well, no, I mean, because the Buddhist thought really doesn't have an other. I mean, some forms of Buddhism have an other, but mainstream Buddhism doesn't have that.
That's good.
So yeah, Buddhism is kind of an interesting wrinkle when you start doing the comparative stuff. So because you have to that's where you end up with this more abstract kind of thing that, well, no, religion's about what I'm saying, feelings and definition and cohesion, and it may be about an other, but not necessarily. Well, what is interesting, I was just actually a friend of mine was just sort of casually asking a question about, sort of what's the difference between different religions, and the thing that stands out, when you're doing comparisons with the big religions, is that they all have a different problem that they see human beings struggling with, sort of fundamental problem. So Buddhist fundamental problem is desire. The Jewish fundamental problem is social justice. The Christian fundamental problem is sin, and this relationship with the divine, with sin. So they all have this sort of, so that's kind of curious too in and of itself, right? That why is it people would all have a universal opinion that there's something wrong. They need to fix it.
Mm-hmm.
But that's kind of, I mean, it's not it's not clear that you could really argue that with animism, that there's a I mean, other than control. You know, the animist has a fundamental understanding and control problem that they're
Say more
solving.
about that. Who's controlling who?
Yeah, well, exactly. That's what they're not clear on that.
Oh, well,
There's those spirits they're worried about, you know, so they control us, but we try to control them. So
if we give sacrifices, they'll be good to us.
that kind of thing.
They're out to hurt us mostly,
Mhm.
make our lives miserable.
Or we'll burn the reins, you know. So I mean, it can be encouraging favorable thing as well as discouraging unfavorable. It goes
Yeah.
both directions.
Yeah, yeah.
I was thinking for the most part, can you hear me?
Yeah.
For the most part, our science fiction stories have been nefarious invaders. Also,
Huh. Mm-hmm. Problems. Yeah.
And I mean,
I have a sort of a different question.
Uh-huh.
This and if I turn myself off here, anyway, let me turn myself off. But I laughed out loud at this, and I had a question for you about it. It's one of your little Roman numeral things at the bottom of the page. And in my working life, I was a science teacher, and so it was really interesting to me where you wrote, science is a powerful and potentially liberating tool, and superstition is a powerful control mechanism. Thus, the current debate about teaching so-called intelligent design in science classes. I have taken to saying that teaching intelligent design in science class is like teaching rolling your own cigarettes in health class. And as I said, I laughed out loud at that, having dealt kind of with that. But my question to you is, that's such an interesting connection. Where did you think of that? How did you think of that?
That analogy?
Yeah.
It was just sort of, it just, you know, came to me, this sort of, if you're teaching the thing that's undermining the thing you're trying to teach. So in health class, you're undermining health. So in science class, you're undermining science by.
Oh, well, that's simple enough. Very good.
Philosophy loves good analogies.
Right. Yeah, excellent. I apologize for this. I think I'm just going to stop my video and listen.
Oh, that's no problem. Yeah.
Okay,
Janet, you have your hand.
Yeah, so going back to the comparison aspect with Buddhism, where the problem is desire, it's funny because we were having this discussion at dinner last night with some friends of ours. So if religion is these three things, and the first is emotion, then emotion, I mean, desire an emotion. I mean, then it's saying, then that religion would be something that goes against our most basic selves. So does that make it the exception again, or is desire not an emotion?
Well, it's the desire piece. I mean, all of them, I think, are they don't necessarily, you know, approach them all in an organized way. So if all three are going on, all three be mixed up all at the same time. So it's So I'm not sure I'd want to sort of come at that, because I think there are different ways. In all three of those categories, you can argue there are different ways that the Buddhist thought is coming at the problem.
Okay. Yeah. Okay. Because I was just, you know, if we're trying to get rid of desire, then the emotion aspect of the system would be.
Well, one part of it is because you're wanting to calm those emotions.
Yeah. Right.
Yeah.
Okay. Or observe them and not be consumed by them or something. Okay.
Yeah. Nikki?
Yeah, that's kind of what I was going to say. My understanding is it's desire in a negative way, that you're jealous or you're coveting. That's what you try to tamp down. Belief.
Yeah, I mean, you need food, so wanting food is not an inherently bad thing, but too much food would be a bad thing. Okay.
I had a question in that vein also. I mean, I finally got the book. It took about a week for Barnes and Noble, but it came. And so I was looking at where it breaks it down with emotional, existential, and social. And it, to me, there's a whole world of feeling. I suppose is that that if you're purely intellectual about it, you kind of divorce yourself from the feeling, I think. So I didn't know whether you were intending to divorce yourself from whatever feelings there are in there or not when you put it. And that's in chapter 1 on page 10 or whatever. You break it down with emotional, existential, and social. And
I think, well, I mean, what the biggest thing that I think that's going on is really to do with that kind of cognitive map that your brain wants to have a sense of what's going on. And so if something happens that's really dramatic or emotional and you don't know what that is, that gets to be really, really disruptive. So I was just thinking about this the other day. I walked out of Costco and I forgot which lane I had parked the damn car in. And so for 5 minutes, I'm wandering around, and there's a point at which that gets to be kind of a distressing kind of experience, because you feel like your grasp of reality has suddenly been taken away a little bit. Like, I should know where my car is. I left it there. And the fact that I don't means something's very, very wrong. And so it's that possibility of being overwhelmed that I think is that's what's motivating the religious response. So how it's going to navigate in particular emotions are going to be very, I think, particularized, but it's this basic fact of we need to be able to control the emotional response in general.
Yeah, but I think the individual censors himself, and so your threshold for saying, "Boy, I did a bad job there," is different from other people, and so that's also variable in a way too.
Oh yeah,
yeah.
Okay, Catherine.
Yeah, I'm just going back to the contrast that you started out with different religions, and it made me think of the Spanish evangelization in Mexico. Of course, the Christians came in with the struggle between good and evil, and basically the Aztec struggle was between order and chaos. And I mean, I don't think that was something that the evangelizers were even aware of or cared to think about.
Right.
I think that's something, and I know very little about pre-Hispanic religion, but that part stuck with me. And then, of course, from then on, it was somehow mediating between the two visions of the world until you come up with some different forms of Christianity and within Catholicism within Mexico. Anyway, that's all.
Yeah, no, it's a good example. Yeah, and also how one can have a hard time understanding the other, because if you're used to thinking about the world a certain way and someone else comes at you and says, well, no, there's a different issue going on. That's fundamental.
Yeah, right.
What do you mean there's a different issue?
So that's where the human sacrifice came from.
Yep.
It somehow responded to that. I'm not sure how, but
yeah. Well, I use it. I think I do talk about this probably I think in the social piece, but it's worth mentioning here. It's a powerful logical tangle to get oneself into, because if you do something and something else follows from it that you want, you're going to be naturally inclined to try and repeat that. And if for some reason it seems like it's working to you, then you get into this cycle where you can't imagine, where if the issue is big enough, you can't actually test it, because the consequence of you being wrong is so big that it's chaos, right? You stop the sacrifices, you unleash utter chaos into the world. So you can't test your theory that your sacrifices are what's maintaining the order, because if that's wrong, you get chaos. And so they're stuck in this system in which that's the ritual that has to go forward. And it's one wonders, what would, if they had been left alone long enough, what kind of reform movement would it take to dramatically change that worldview? but because at some point it would, presumably, but it's interesting how you can get caught that way by your own worldview.
Richard, then
Mhm.
just to make sure I understand part of the basis is that science has discovered that all sensory input goes through the amygdala and hippocampus before going to our more rational part of the brain.
Mm-hmm.
Is that correct? Is
Yes.
that my understanding correct? That just blew my mind.
Yes.
And just as a side, because I speak Greek, every time I hear amygdala, all I think about is almonds.
Oh, yeah, that's where the name comes from, right? Yeah.
Yeah, because it's pronounced almost exactly the same way.
Oh. Yeah. So yeah, the bigger point there is we've been told over and over again our whole lives that human beings are rational, that
Right.
and thoughtful and reasoned, and that's what's different about us. And in fact, that's the big thing I want you all to come away from class with, an understanding of that's just fundamentally wrong, that we are at core emotional beings, and the reason is just a tool that's useful at times if the emotions let it come out. Janet?
Yeah, I wanted to ask, so I wanted to talk about this book, Who's in Charge, by Michael Gazzaniga. And it's about free will and brain science. And he basically disputes the idea that we don't have free will, but does go into a lot of those things that Joanne was just talking about. So a lot of the theories about not having free will are based on this separation, and he disputes that, but he does in the process explain a lot about how the brain works, and it was very readable. So if people want to learn more about the brain and the emotional responses and sensory responses, I would recommend it.
Cool.
It's from 2011, so I'm sure brain science has changed even since then.
Moved a little bit, yeah. And the stuff I'm showing you is actually a little older too, because that's the references I have.
Yeah, but I mean, it's chapters on the social mind and a lot about the emotional aspect and how we respond to something before our conscious mind takes over, as you talked about in your book. So anyway, just more info.
Cool. Okay, so I think so. Today, I want to introduce you to the neuroscientists that I've been relying on, and to give you a sense of sort of their work as a way of beating in this "we're emotional creatures" idea and how that's working. So I have some videos to show you, and some of them I think are really really pretty impressive. Especially the one with Ramachandran, I'll show you. Let me see, I need to share a screen here. See if we can find something. Okay, so I thought I'd start with Dan Siegel. I don't really I get to him farther along in the chapter, but he has this wonderful kind of overview that he uses to explain kind of the basic structures of the brain and how they're relating to each other. And so I think it's an interesting way to start. Now, the thing that's I think kind of interesting about Siegel to keep in mind about how he does all of this is that he is a psychiatrist. So he's interested in neuroscience because of because of that profession, but he's fundamentally a physician in the business of healing people. Where Ramachandran and Damasio, the other two people I spend a lot of time talking about, are neuroscientists whose professional work is in a laboratory. It's not in a hospital. So Siegel's interesting because he's a bridge between those two worlds.
My name is Dan Siegel, and it's an honor to introduce you to the hand model of the brain. Sometimes the brain in our head is modeled as a plastic model, like the one you see here, that's 2 times life size. And it's fun to carry a big model around this size because you can take it apart and look at some of the insides and see what's going on. But it's hard to carry this around in everyday life. So what I invented was a model of the brain that you actually have in your hand. My daughter has urged me not to call it a handy model, but it is kind of handy. And the model goes like this. If this brain were oriented in my head in this direction, with this frontal part here behind the forehead, we would create this in our hand model by putting our thumb in the middle, our fingers over the top, and this would be oriented this way. Now, the hand model of the brain is very useful because when you know about the parts of the brain, you can learn how to direct your attention in a way that can get certain areas to not only get activated, but also to start to work together. And you can change both the function and the structure of your brain by knowing about how the brain is structured. So let's walk through these areas of the brain and how they can link together. This hand model of the brain has been useful in classrooms. It's been useful in corporate offices. It's been useful for mediation, for meditation, for people out in the field working with the stresses of working with epidemics, and for people who are just in general trying to improve their lives. So let's go through this hand model and see how it can support your work and your life. If you take your hand and put your thumb in the middle and fold your fingers over the top, this would be the completed model. The top of the brain is called the cortex and would be represented in your fingers. If you lift up the cortex, you'll see beneath it the limbic area, which should have 2 thumbs to be a perfect model, but most of us just have 1. And in this limbic area, you see that there are connections upwards to the cortex and even downwards to the area just below it called the brain stem in your palm. And this whole head brain is connected to the body through a number of regions, including the spinal cord represented in your wrist. Now let's quickly review what these areas do, and you can see how what you do with your mind can change the way the brain functions. If we lift up the cortex and lift up the limbic area, let's begin with the brainstem. The brainstem is the oldest part of this head brain, and I keep on saying head brain because you have neurons around your heart and around your intestines that people are calling the gut brain and the heart brain. And so I'll use the word just brain, but actually it's a hand model of the head brain. The deepest, oldest part of the head brain
Actually, sort of on that, this is,
brainstem.
oh, no.
It takes
What am I doing? Okay. That's actually kind of a useful point that because it turns out, I remember hearing there are more neurotransmitters around your gut than in your brain. And so just on that level, you sort of think about how we sort of talk about feelings and gut feelings and all of that. And that, you know, it sort of makes more sense when you know all of this stuff. But it's also a sign about how much of that emotional life is not necessarily in your brain. It might be in your gut.
in information from the body, and it helps regulate things like how you breathe and how you digest food, how your heart functions. In addition, the brainstem has a very important set of regions that create the fight, flight, freeze, and faint response that comes when we feel threatened. So if you're working in a business, for example, or you're in a classroom or you're at home and you feel threatened by what's going on, the brainstem gets involved to create this reactive state. In addition, this brainstem works closely with, if you put your next area down, the thumb region, which is the limbic area. This is a 200 million year old region when we became mammals that works with the 300 million year old reptilian brain. And together they work to create emotion in working with the body. The body, brainstem, limbic area create emotion. The brainstem works with the limbic area to also motivate.
And here it's worth pointing out this language, feeling, emotion. And the different these different researchers are going to have a little bit different ways of using those terms. So you just see if you notice, at least try to keep track of that they may mean slightly different things with the word emotion compared to the word feeling. Damasio is going to be the most specific about it.
Us to drive our behaviors. And this limbic area appraises the meaning of things, whether things are significant or not, whether they're good or bad. In addition, there are certain ways memory is divided up and connected through the limbic area with an area you may have heard, the hippocampus, or with its amygdala region. And then on top of that, you have the attachment experience we have as mammals, where we connect with caregivers so that they can protect us and we can be soothed by them, is also mediated by this limbic region, not just in childhood, but throughout our whole lifespan. Now, these limbic functions work closely, if you fold your fingers over, with the cortex, which is basically making maps. So this region makes maps of the outside world with our eyes in the back, the occipital cortex. Sound comes in the side, the temporal lobe, with the way in which we map out sound. And you even have an area in the front from these second to last knuckles forward called the frontal cortex, also known as the association cortex, where you make associations in thought. And the frontmost part of this frontal lobe here is demarcated by your last knuckles down to your fingernails, and this is called the prefrontal cortex. Now, you may have heard a lot about the prefrontal cortex because it's involved basically in something called integration. It integrates cortex, limbic area, you can see it sits on top of it, brainstem, body, and even the social world together. Now, when you do a practice, let's say like we have a wheel of awareness practice as a form of mindfulness meditation, or do any kind of mindfulness reflective practice, you are integrating the whole system. When you're not integrated, it can become chaotic and rigid. It's like flipping your lid. So instead of living with harmony within yourself and harmony and connection to others, you're literally becoming chaotic with an outburst or rigid and withdrawn. That's demonstrated by literally lifting up your fingers and showing how this prefrontal region is no longer linking the cortex, limbic area, brainstem, body, and the social world. It's become disintegrated. Now, the amazing thing is there's a new set of studies called the connectome studies, which show how the areas of the brain that are differentiated can then become connected. So it's connectome. And what research has shown from the Human Connectome Project is the best predictor of your well-being is how interconnected your connectome is. So anything you can do to understand your hand model of the brain and to bring an honoring of differences and a connection of these areas, you'll be promoting integration and you'll be giving yourself the gift that keeps on giving. And the amazing thing too is that integration is likely the source of well-being, not just in our bodies, including the head brain, but in our relationships with other people and even with nature around us. Creativity emerges from this integration. Collaboration emerges from integration. So the hand model of the brain reminds us to know the different parts, understand how they may be differentiating themselves if we're angry or getting upset, feeling sad, feeling lonely, making thoughts that emerge, and then opening ourselves to all of these and connecting them together. Whether you do this in the wheel of awareness practice or some other kind of reflective practice, having this brain of yours become more integrated is the pathway toward more well-being in your life, whether it's at work, at home, or in your communities. Integration creates well-being. Thanks for joining me.
Okay, now
Goodbye.
how am I going to make this smaller? Oh, here we are. Okay. Whoop. So my wife's a clinical social worker. She uses that little hand trick in therapy sometimes with her clients. Okay, so that just sort of an overview to get you started. I have Ramachandran up next to fill in some fun details. And he's also an amazing speaker, which people will comment about in his videos, but you'll see it. Any questions about this before we go on? Okay, yeah, we'll get to the real meat coming up here.
Chris pointed out, I study the human brain, the functions and structure of the human brain. And I just want you to think for a minute about what this entails. Here is this mass of jelly, 3-pound mass of jelly, you can hold in the palm of your hand, and it can contemplate the vastness of interstellar space. It can contemplate the meaning of infinity, and it can contemplate itself contemplating on the meaning of infinity. And there is this peculiar recursive quality that we call self-awareness, which I think is the holy grail of neuroscience, of neurology, and hopefully someday we'll understand how that happens. Okay, so how do you study this mysterious organ? I mean, you have 100 billion nerve cells, little wisps of protoplasm, interacting with each other. And from this activity emerges the whole spectrum of abilities that we call human nature and human consciousness. How does this happen? Well, there are many ways of approaching the functions of the human brain. One approach, the one we use mainly, is to look at patients who have sustained damage to a small region of the brain. Or there's been a genetic change in a small region of the brain. What then happens is not an across-the-board reduction in all your mental capacities, a sort of blunting of your cognitive ability. What you get is a highly selective loss of one function with other functions being preserved intact. And this gives you some confidence in asserting that that part of the brain is somehow involved in mediating that function. So you can then map function onto structure and then find out what the circuitry is doing to generate that particular function. So that's what we're trying to do. So let me give you a few striking examples of this. In fact, I'm giving you 3 examples, 6 minutes.
Yeah, there's a psychologist I quote a little bit later on in the chapter named Vygotsky, who is a Soviet psychologist, and he was one of the first people to really kind of get a grasp on different brain structures and how they were working. And it's because there was a world war called World War II, and there were all these people who had head injuries, and he could try to help them, but in doing so come to understand, well, if this part gets damaged, this happens. And so Ramachandran just is following along in that same kind of methodology. When patients present themselves, it's an opportunity to learn, and so that's what they do.
Also, could people mute, because there's a lot of feedback.
Oh, okay, yeah. I feel like there's something happening behind me. I can't quite identify, but hope you're not hearing that. A little buzzy thing. Anyway.
The first example is an extraordinary syndrome called Capgras syndrome. If you look at the first slide there, that's the temporal lobes, frontal lobes, parietal lobes, okay, the lobes that constitute the brain. And if you look tucked away inside the inner surface of the temporal lobes, you can't see it there, is a little structure called the fusiform gyrus. And that's been called the face area in the brain, because when it's damaged, you can no longer recognize people's faces. You can still recognize them from their voice, say, oh yeah, that's Joe. But you can't look at their face and know who it is. Right? You can't even recognize yourself in the mirror. I mean, you know it's you, because when you wink, it winks and you know it's a mirror. But you don't really recognize yourself as yourself. Okay, now that syndrome is well known. It's caused by damage to the fusiform gyrus. But there's another rare syndrome, so rare, in fact, that very few physicians have heard about it, not even neurologists. This is called the Capgras delusion. And that is a patient who's otherwise completely normal, who's had a head injury, comes out of coma, otherwise completely normal. He looks at his mother and says, this looks exactly like my mother, this woman, but she's an imposter. She's some other woman pretending to be my mother. Now, why does this happen? Why would this person is perfectly lucid and intelligent in all of the respects, but when he sees his mother, this delusion kicks in, says not mother. Now, the most common interpretation of this, which you find in older psychiatry textbooks, is a Freudian view. And that is that this chap, and the same argument applies to women, by the way, but I'll just talk about guys. When you were a little baby, when a young baby, you had a strong sexual attraction to your mother. This is the so-called Oedipus complex of Freud. I'm not saying I believe this, but this is the standard Freudian view. And then as you grow up, the cortex develops and inhibits these latent sexual urges towards your mother. Thank God, otherwise we'd all be sexually aroused when you saw your mother. And then what happens is there is a blow to your head, damaging the cortex, allowing these latent sexual urges to emerge, flaming to the surface, and suddenly and inexplicably, you find yourself being sexually aroused by your mother. You say, my God, if this is my mom, how come I'm being sexually turned on? She's some other woman. She's an imposter. It's the only interpretation that makes sense to your damaged brain. This never made much sense to me, this argument. It's very ingenious, as all Freudian arguments are. Didn't make much sense because I have seen the same delusion, a patient having the same delusion about his pet poodle. He'll say, doctor, this is not Fifi. It looks exactly like Fifi, but it's some other dog, right? Now you try using the Freudian explanation there. You have to start talking about the latent bestiality in all humans or some such thing, which is quite absurd, of course. Now, what's really going on? So to explain this curious disorder, we look at the structure and functions of the normal visual pathways in the brain. Normally, visual signals come into the eyeballs, go to the visual areas in the brain. There are, in fact, 30 areas in the back of your brain concerned with just vision. And after processing all that, the message goes to a small structure called the fusiform gyrus, where you perceive faces. There are neurons there that are sensitive to faces. You can call it the face area of the brain, right? I talked about that earlier. Now, when that area is damaged, you lose the ability to see faces, right? But from that area, the message cascades into a structure called the amygdala in the limbic system, the emotional core of the brain. And that structure called the amygdala gauges the emotional significance of what you're looking at. Is it prey? Is it predator? Is it mate? Or is it something utterly trivial like a piece of lint or a piece of chalk or I don't want to point to that, but or a shoe or something like that, okay? Which you can completely ignore. So if the amygdala is excited, and this is something important, the messages then cascade into the autonomic nervous system. Your heart starts beating faster. You start sweating to dissipate the heat that you're going to create from exerting muscular exertion. And that's fortunate because you can put 2 electrodes on your palm and measure the change in skin resistance produced by sweating. So I can determine when you're looking at something whether you're excited or whether you're aroused or not. Okay, and I'll get to that in a minute. So my idea was when this chap looks at an object, when he looks at any object for that matter, it goes to the visual areas, and however, and it's processed in the fusiform gyrus, and you recognize it as a pea plant or a table or your mother for that matter, okay? And then the message cascades into the amygdala and then goes down the autonomic nervous system. But maybe in this chap, that wire that goes from the amygdala to the limbic system, the emotional core of the brain, is cut by the accident. So because the fusiform is intact, the chap can still recognize his mother and says, oh, yeah, this looks like my mother. But because the wire is cut to the emotional centers, he said, but how come if it's my mother, I don't experience a warmth or terror, as the case may be, right? And therefore, he says, how do I account for this inexplicable lack of emotions? This can't be my mother. It's some strange woman pretending to be my mother. How do you test this? Well, what you do is if you take any one of you here.
Okay, now what I think I really want you to catch here, right, is how important the emotion is in the story that he's telling. That vital details about what reality is are being determined by this subtle emotional response that you're either noticing or not noticing, and the patient is generally not able to articulate any of that, right? That's what they're feeling that's motivating the sort of cognitive determination that I'm looking at an imposter. But so it's subtle and it's small things, and also just even that there's this one little bitty part of the brain that gets a little damaged, and all of a sudden you can't see faces anymore. That it's that what's going on is really kind of on a knife's edge. And so that's sort of part of my argument about why you would have to have this a social structure to come in and give you material so that your brain knows how to navigate any kind of severe disruption, because we're so easy prey to small disruptions, because this organ, the brain, is so finely tuned. And so the subtlety of that, I think, is really, really important.
And put you in front of a screen and measure your galvanic skin response and show pictures on the screen. I can measure how you sweat when you see an object like a table or an umbrella. Of course, you don't sweat. If I show you a picture of a lion or a tiger or a pinup, you start sweating, right? And believe it or not, if I show you a picture of your mother, I'm talking about normal people, you start sweating. You don't even have to be Jewish. Yeah. Now, what happens if you show this patient? You take the patient and show him pictures on the screen and measure his galvanic skin response. Tables and chairs and lint, nothing happens, as in normal people. But when you show him a picture of his mother, the galvanic skin response is flat. There's no emotional reaction to his mother because that wire going from the visual areas to the emotional centers is cut. So his vision is normal because the visual areas are normal. His emotions are normal. He'll laugh, he'll cry, so on and so forth. But the wire from vision to emotions is cut, and therefore he has this delusion that his mother is an imposter. It's a lovely example of what the sort of thing we do. Take a bizarre, seemingly incomprehensible neuropsychiatric syndrome and say that the standard Freudian view is wrong, that in fact you can come up with a precise explanation in terms of the known neuroanatomy of the brain. By the way, if this patient then goes and mother phones from an adjacent room, phones him, and he picks up the phone, he says, "Wow, Mom, how are you? Where are you?" There's no delusion through the phone. Then she approaches him after an hour. He says, "Who are you? You look just like my mother." Okay. The reason is there's a separate pathway going from the hearing centers in the brain to the emotional centers, and that's not being cut by the accident. So this explains why with a phone, he recognizes his mother, no problem. When he sees it in person, he says it's an imposter. Okay. Now, how is all this complex circuitry set up in the brain? Is it nature, genes, or is it nurture? And we approach this problem by considering another curious syndrome called phantom limb. And you all know what a phantom limb is. When an arm is amputated or a leg is amputated for gangrene, or you lose it in war, for example, in the Iraq war, it's now a serious problem. You continue to vividly feel the presence of that missing arm, and that's called a phantom arm or a phantom leg. In fact, you can get a phantom with almost any part of the body. Believe it or not, even with internal viscera. I've had patients with the uterus removed, hysterectomy, who have a phantom uterus, including phantom menstrual cramps at the appropriate time of the month. And in fact, one student asked me the other day, do they get phantom PMS? Subject ripe for scientific inquiry, but we haven't pursued that. Okay, now the next question is, what can you learn about phantom limbs by doing experiments? One of the things we found was about half the patients with phantom limbs claim that they can move the phantom. It'll pat his brother on the shoulder, it'll answer the phone when it rings, it'll wave goodbye. These are very compelling, vivid sensations. Patient's not delusional, he knows that the arm is not there, but nevertheless, it's a compelling sensory experience for the patient. But however, about half the patients, this doesn't happen. The phantom limb, they'll say, "Doctor, the phantom limb is paralyzed. It's fixed in a clenched spasm and is excruciatingly painful. If only I could move it, maybe the pain will be relieved." Now, why would a phantom limb be paralyzed? It sounds like an oxymoron. When we looked at the case sheets, what we found was these people with the paralyzed phantom limbs, the original arm was paralyzed because of a peripheral nerve injury. The actual nerve supplying the arm was severed, was cut by, say, a motorcycle accident. So the patient had an actual arm, which is painful, in a sling for a few months or a year. And then in a misguided attempt to get rid of the pain in the arm, the surgeon amputates the arm. And then you get a phantom arm with the same pains, right? And this is a serious clinical problem. Patients become depressed. Some of them are driven to suicide, okay? So how do you treat this syndrome? Now, why do you get a paralyzed phantom limb? When I looked at the case sheet, I found that they had an actual arm, and the nerve supplying the arm had been cut, and the actual arm had been paralyzed and lying in a sling for several months before the amputation, and this pain then gets carried over into the phantom itself. Why does this happen? When the arm was intact but paralyzed, the brain sends commands to the arm, the front of the brain, saying, "Move." But it's getting visual feedback saying, "No, move, no, move, no, move, no." And this gets wired into the circuitry of the brain, and we call this learned paralysis. Okay, the brain learns because of this Hebbian associative link that the mere command to move the arm creates a sensation of a paralyzed arm. And then when you amputate the arm, this learned paralysis carries over into your body image and into your phantom. Okay? Now, how do you help these patients? How do you unlearn the learned paralysis so you can relieve him of this excruciating clenching spasm of the phantom arm? Well, we said, what if you now send the command to the phantom, but give him visual feedback that it's obeying his command, right? Maybe you can relieve the phantom pain, the phantom cramp. How do you do that? Well, virtual reality, but that costs millions of dollars. So I hit on a way of doing this for $3, but don't tell my funding agencies. Okay. What you do is you create what I call a mirror box. You have a cardboard box with a mirror in the middle, and then you put the phantom. So my first patient, Derek, came in. He had his arm amputated 10 years ago. He had a brachial avulsion. So the nerves were cut. The arm was paralyzed, lying in a sling for a year. And then the arm was amputated. He had a phantom arm, excruciatingly painful, and he couldn't move it. It was a paralyzed phantom lung. So he came there, and I gave him a mirror like that in a box, okay, which I call a mirror box, right? And the patient puts his phantom left arm, which is clenched and in spasm on the left side of the mirror, and the normal hand on the right side of the mirror, and makes the same posture, the clenched posture, and looks inside the mirror. And what does he experience? He looks at the phantom being resurrected, because he's looking at the reflection of the normal arm in the mirror, and it looks like this phantom has been resurrected. Now I said, now look, wiggle your phantom, your real fingers, or move your real fingers while looking in the mirror. He's going to get the visual impression that the phantom is moving, right? That's obvious. But the astonishing thing is the patient then says, oh my God, my phantom is moving again. And the pain, the clenching spasm is relieved. I remember my first patient who came in.
Yeah, that's just genius that he could figure that out. And again, the subtlety of it all is too, the thing I want you to track is that it's this little bit of visual feedback is having this dramatic effect in what the brain is making out of reality in its experience. And it can be just little things.
My first patient came in and he looked in the mirror and I said, look at your reflection of your phantom. And he started giggling so that I can see my phantom. But he's not stupid. He knows it's not real. He knows it's a mirror reflection, but it's a vivid sensory experience. Now I said, move your normal hand and phantom. He said, oh, I can't move my phantom. You know that. It's painful. I said, move your normal hand. And he says, oh my God, my phantom is moving again. I don't believe this. And my pain is being relieved. Okay. And then I said, close your eyes. He closed his eyes and move your normal hand. Oh, nothing. It's clenched again. Okay, open your eyes. Oh my God, it's moving again. So he's like a kid in a candy store. So I said, okay, this proves my theory about learned paralysis and the critical role of visual input. But I'm not going to get a Nobel Prize for getting somebody to move his phantom limb. It's a completely useless ability if you think about it. But then I started realizing maybe other kinds of paralysis that you see in neurology, like stroke, focal dystonias, there may be a learned component to this, which you can overcome with the simple device of using a mirror. So I said, look, Derek, well, first of all, the guy can't just go around carrying a mirror to alleviate his pain. I said, look, Derek, take it home and practice with it for a week or two. Maybe after repeated practice, you can dispense with the mirror, unlearn the paralysis, and start moving your paralyzed arm, and then relieve yourself of pain. So he said, okay, and he took it home. I said, look, it's after all $2, take it home. So he took it home, and after 2 weeks, he phones me, and he said, doctor, you're not going to believe this. I said, what? He said, it's gone. I said, what's gone? I thought maybe the mirror box was gone. He said, no, you know, this phantom I've had for the last 10 years, it's disappeared. And I said, I got worried. I said, my God, I've changed this guy's body image. What about human subjects, ethics, and all of that? And I said, Derek, does this bother you? He said, no. Last 3 days, I've not had a phantom arm, and therefore no phantom elbow pain, no clenching, no phantom forearm pain. All those pains have gone away. But the problem is I still have my phantom fingers dangling from the shoulder, and your box doesn't reach. So can you change the design and put it on my forehead so I can, do this and eliminate my phantom fingers? He thought I was some kind of magician. Now, why does this happen? It's because the brain is faced with tremendous sensory conflict. It's getting messages from vision saying the phantom is back. On the other hand, there's no proprioception, muscle signals saying that there is no arm, right? And your motor command saying there is an arm. And because of this conflict, the brain says, to hell with it, there is no phantom. There is no arm, right? It goes into a sort of denial. It gates the signals. And when the arm disappears, The bonus is the pain disappears because you can't have disembodied pain floating out there in space. So that's the bonus. Now, this technique has been tried on dozens of patients by other groups in Helsinki, so it may prove to be valuable as a treatment for phantom pain. And indeed, people have tried it for stroke rehabilitation. Stroke, you normally think of as damage to the fibers, nothing you can do about it. But it turns out some component of stroke paralysis is also learned paralysis. And maybe that component can be overcome using mirrors. This has also gone through clinical trials, helping lots and lots of patients. Okay, let me switch gears now to the third part of my talk, which is about another curious phenomenon called synesthesia.
Yeah, this one is the one that's most interesting to me.
This is discovered by Francis Galton in the 19th century. He was a cousin of Charles Darwin. He pointed out that certain people in the population who are otherwise completely normal have the following peculiarity. Every time they see a number, it's colored. 5 is blue, 7 is yellow, 8 is chartreuse, 9 is indigo. Okay? Bear in mind, these people are completely normal in other respects. Okay? Or C sharp, sometimes tones evoke color. C sharp is blue, F sharp is green. Another tone might be yellow, right? Why does this happen? This is called synesthesia. Galton called it synesthesia, mingling of the senses. In us, all the senses are distinct. These people muddle up their senses. Why does this happen? Another two aspects of this problem are very intriguing. Synesthesia runs in families. So Dalton said this is a hereditary basis, a genetic basis. Secondly, synesthesia is about, and this is what gets me to my point about the main theme of this lecture, which is about creativity. Synesthesia is 8 times more common among artists, poets, novelists, and other creative people than in the general population. Why would that be? I'm going to answer that question. It's never been answered before. Okay. What is synesthesia? What causes it? Well, there are many theories. One theory is they're just crazy. Now, that's not really a scientific theory, so you can forget about it, okay? Another theory is they're acid junkies and potheads, right? Now, there may be some truth to this because it's much more common here in the Bay Area than in San Diego. Okay. Now, the third theory is that, well, let's ask ourselves what's really going on in synesthesia, all right? So we found that the color area and the number area are right next to each other in the brain, in the fusiform gyrus. So we said there's some accidental cross-wiring between color and numbers in the brain. So every time you see a number, you see a corresponding color, and that's why you get synesthesia. Now, remember, why does this happen? Why would there be cross-wired in some people? Remember I said it runs in families. That gives you the clue. And that is there is an abnormal gene, a mutation in the gene that causes this abnormal cross-wiring. In all of us, it turns out we are born with everything wired to everything else. So every brain region is wired to every other region. And these are trimmed down to create the characteristic modular architecture of the adult brain. So there's a gene causing this trimming. And if that gene mutates, then you get deficient trimming between adjacent brain areas. And if it's between number and color, you get number color synesthesia. If it's between tone and color, you get tone color synesthesia. So far, so good. Now, what if this gene is expressed everywhere in the brain? So everything is cross-connected. Well, think about what artists, novelists, and poets have in common. The ability to engage in metaphorical thinking, linking seemingly unrelated ideas, such as it is the east and Juliet is the sun. But you don't say Juliet is the sun. Does that mean she's a glowing ball of fire? I mean, schizophrenics do that, but it's a different story, right? Normal people say she's warm like the sun, she's radiant like the sun, she's nurturing like the sun. Instantly you form the links. Now, if you assume that there's greater cross-wiring and concepts are also in different parts of the brain, then it's going to create a greater propensity towards metaphorical thinking and creativity in people with synesthesia. And hence, the 8 times more common incidence of synesthesia among poets, artists, and novelists. Okay, it's a very phrenological view of synesthesia. The last demonstration, can I take 1 minute? I'm going to show you that you're all synesthetes, but you're in denial about it. Here's what I call Martian alphabet. Just like your alphabet, A is A, B is B, C is C, different shapes for different phonemes, right? Here you've got Martian alphabet. One of them is Kiki, one of them is Booba. Which one is Kiki and which one is Booba? How many of you think that's Kiki and that's Booba? Raise your hands. Well, it's 1 or 2 mutants. How many of you think that's Booba, that's Kiki? Raise your hands. 99% of you. Now, none of you is a Martian. How did you do that? It's because you're all doing a cross-modal synesthetic abstraction, meaning you're saying that that sharp inflection, ki, in your auditory cortex, the hair cells being excited, ki, mimics the visual inflection, sudden inflection of that jagged shape. Now, this is very important because what it's telling you is your brain is engaging in a primitive, it looks like a silly illusion. But these photons in your eye are doing this shape, and hair cells in your ear are exciting the auditory pattern, but the brain is able to extract the common denominator. It's a primitive form of abstraction. And we now know this happens in the fusiform gyrus of the brain, because when that's damaged, these people lose the ability to engage in Buba Kiki, but they also lose the ability to engage in metaphor. If you ask this guy, what all that glitters is not gold, what does that mean? The patient says, well, if it's metallic and shiny, it doesn't mean it's gold. You have to measure its specific gravity. Okay, so they completely miss the metaphorical meaning. So this area is about 8 times the size in higher, especially in humans, as in lower primates. Something very interesting is going on here in the angular gyrus, because it's the crossroads between hearing, vision, and touch, and it became enormous in humans, and something very interesting is going on. And I think it's a basis of many uniquely human abilities like abstraction, metaphor, and creativity. All of these questions that philosophers have been studying for millennia, we scientists can begin to explore by doing brain imaging and by studying patients and asking the right questions. Thank you.
So, yeah, that. Why do people tell mythical stories? Synesthesia, because we all have synesthesia. We all have a natural propensity to metaphors. I mean, it's an astounding thing. And one of the things also we just sort of is illustrating along the way is this point about studying people and studying brains and making these generalizations. And there are times when it's hard to know, like, is it just, if he finds something in a patient, is that, well, did I find something that's idiosyncratic to this patient, or did I find something that's universal in humanity? And after you found a few more people, you start to feel comfortable you're generalizing. But it's interesting how this little bitty detail about brains, you can find this in a few people, and all of a sudden you've understood something really profound about all of human beings, or other than that, the 1% who didn't quite get it in his audience. But you've found this thing that's remarkably generalizable about people, that is getting at culture and how culture's working and how we see significance in cultural forms. And it's because we're all prone to metaphorical thinking.
Richard, I've watched a couple of TV series that have as characters autistic people who have a unique, extraordinary ability. But the thing I noticed, it was very interesting, in both characters, different series, they don't understand metaphors at all. At least that's how they're portrayed. And I don't know if that's a true trait of autistic folks, but I found that interesting. Yeah, they didn't get the metaphors at all. They were very literal.
Yeah, and once you recognize that we have that capacity, and when you see it in stark, especially that kind of stark relief. Yeah, interesting. Yeah, I had the basic idea of that I was coming up with about the 3 kind of fundamental roles that came up to me after I finished my master's degree. But it wasn't until I started doing my dissertation and started reading more of this psychology that this kind of stuff started popping up to me. And so it was like, wait a second, wow, it's not just that I can explain what religion's doing, but now we can explain why religion is doing it. And it's this, so that's really what the book is sort of about, is putting these 2 ideas together, that we have these cultural forms because of the way our brains work. And that actually is really an important thing to know about us. Okay. How are we doing? 12:30. All right. I have a couple more little shorter ones. How are we doing? Okay. So the next step is actually the one that to take with Damasio. And so with him, what we're getting is a little bit more sophisticated understanding between what's happening sort of physiologically in terms of you know the hormones and neurotransmitters that get kicked up that are kind of the physiological cause of feelings. I think I had that right with his wording. And then there is the understanding that's being layered into that kind of physiological feeling that becomes the kind of human experience of emotion. And so he's kind of a bridge, I think, between brain structures and culture to help us see some relationship there. All right, so that's Damasio. Oops, what am I doing here? Get back there. I need that share thing. There we go. So, okay, here he is. Oh, Damasio, by the way, interesting guy, not quite as flamboyant as Ramachandran. I forget her name, but he's married to a woman who is also an astoundingly renowned neuroscientist in her own right. I should remember her name, but I don't.
Feeling of an emotion is a process that is distinct from having the emotion in the first place. So in order to understand what is an emotion, what is a feeling, we need to understand what is an emotion. And an emotion is the execution of a very complex program of actions. Some actions that are actually movements, like movement that you can do, change your face, for example, in fear, or movements that are internal, that happen in your heart or in your gut, and movements that are actually not muscular movements, but rather releases of molecules, say, for example, in the endocrine system into the bloodstream. But it's movement and action in the broad sense of the term. And an emotion consists of a very well orchestrated set of alterations in the body that has as a general purpose making life more survivable by taking care of a danger or taking care of an opportunity, either or something in between. And it's something that is set in our genome and that we all have with a certain programmed nature that is modified by our experience. So individually we have variations on the pattern, but in essence, your emotion of joy and mine are going to be extremely similar. We may express them physically slightly differently, and it's of course graded depending on the circumstance, but the essence of the process is going to be the same, unless one of us is not quite well put together and is missing something. Otherwise, it's going to be the same. And it's going to be the same across even other species. You know, there's we may smile and the dog may wag the tail, but in essence, we have a set program, and those programs are similar across individuals in the species. Then the feeling is actually a portrayal of what is going on in the organism when you're having an emotion. So it's really the next thing that happens. If you have just an emotion, you would not necessarily feel it. To feel an emotion,
his language to me seems intuitively backwards, but it's just sort of important to keep in mind he's wanting to contrast something that's physiological with something that's cognitive, and he's going to call one feeling and call one emotion, and the feeling one is the cognitive one, and the emotion is the sensory one, the body one. Yeah, I would have believed him, put it the opposite way, but he's the expert.
You need to represent in the brain, in structures that are actually different from the structures which lead to the emotion, what is going on in the organism when you're having the emotion. So you can define it very simply as the process of perceiving what is going on in the organism when you are in the throes of an emotion. And that is achieved by a collection of structures, some of which are in the brainstem and some of which are in the cerebral cortex, namely the insular cortex, which I like to mention, not because I think it's the most important. It's not, I actually don't think it's the number one structure controlling our feelings, but I like to mention it because it's something that people didn't really know about. And many years ago, which probably now are going close to 20 years ago, I thought that the insula would be an important platform for feelings. That's where I started. And there was a hypothesis, and turns out that the hypothesis is perfectly correct. And 10 years ago, we had the first experiments that showed that it was indeed so. And since then, countless studies have shown that when you're having feelings of emotion or feelings of a variety of other things, the insula is active. But it doesn't mean that it's the only thing that is active. And there are other structures that are very important as well.
It's everything you wish for. Your site traffic is skyrocketing until
Real quick here.
this happens.
Ah,
Well, you see, emotion very often when you think about how you react to the world, something is happening to you. You're simply going along and you're being confronted by different things, not necessarily very important or significance for your ultimate life, but you are constantly reacting to the world. You're thinking about the world and you're acting on the world. And emotions are engaged when the stakes outside of your organism are fairly high in positive or negative directions. And this, of course, comes from ancient times in biology when you were constantly being subject to potential threats and to potential opportunities. The threats were obvious, for example, predation, or inclement weather, or physical environments where you would be like having a precipice or a hole on the ground. The opportunities are also very easy to see. They would have fundamentally to do with food and with sex. And so the emotions were placed there in evolution as incredibly smart devices that, rather than having you think through the problem, would deliver a solution and make sure that you would act right. It's in a way a contribution to a sort of autopilot that we've inherited through all these millions of years of evolution. So if there is an opportunity, emotion.
and you could also call it intuition. Oh, Bill, do you have a question here? Yep, you're muted. No, you need to unmute. We can't hear you.
Yes,
There we go.
Did I don't know whether you heard what I said, but
No.
when I'm watching, thinking about Vladimir Putin and what is he feeling, if anything, or is he afraid, or was he thinking, or is he taking care of an opportunity? And he's one of the most disconnected people I think I've ever observed, and here he is running part of the world. But so I can't help but kind of, mix that person in with some of the discussions. That's all I'll say.
Well, yeah, see, the oddballs are going to be a problem for these kinds of theories, right? So, and it's that, so
Maybe he has a brain injury. We don't know.
Yeah, so the generalizations are easy to are useful, but they're not reliably 100% universal. So they might be generally true, but there are going to be some exceptions because of how people are formed, or accidents that happen along the way, or so it's hard to know how to translate that in these terms.
Yeah, I don't expect that. But perhaps his mind creates something different, you know, and he's happily lying about stuff or dissociating in a way. Just, so anyhow, I leave it at that.
And-
There
and
are people like
how
that.
fears work, and that, yeah, that's all going to be very idiosyncratic. Yeah, Catherine.
Well, I mean, that he's probably, isn't he probably a sociopath? I mean, can't he mask? I mean, he doesn't maybe have the feelings.
Well, you got to wonder about a lot of national leaders. Yeah, have seem to have a lot of sociopathic traits.
But it shows the limits of the brain research because so much has been done on people with pathologies because they're willing to have their brains sliced open or scanned, whereas getting those kind of approvals to do research for healthy people is a bigger challenge. So that's the problem with a lot of brain research.
But yeah, the people who wander into their field of vision, right? They're a special subset. Yeah.
I mean, that Paul Allen was trying to, expand that field, but it's hard from an ethics point of view to do it.
Yeah. We could compel everyone to participate in big longitudinal studies. We know a lot. Yeah. How do you, Joanne?
When you said intuition, could it also be instinct? Is there a distinction?
I technically, yes.
I think of instinct as something we were born with, like other non-human animals.
Yeah. So what's the psychologists generally would differentiate and say that an instinct is a pattern, is a pattern behavioral response. And so humans don't seem to have a lot of those. There are some arguments about some issues here and there, but that would be the general kind of way that psychologists talk about it, is an instinct is a patterned response, but intuition is just an insight.
A gut feeling, yeah.
Yeah, or gut feeling. Yeah.
Okay.
And again, gut feeling, right? Yeah, there you go.
Is going to make sure that you, at some level, know that it's there and that you're going to have the tendency to act on it. And if there is a threat, you're going to be alerted to it. And even before you're alerted to the threat as such, you're going to be placed in circumstances that are likely to make you either freeze or run away from the danger. Okay, so this is a level of response to the world that is automated. It's largely non-conscious. I mean, it happens non-conscious. Then you take consciousness of it, because once it's happening, once you start feeling what is happening and connecting the feeling to what you're perceiving, then you realize, aha, there's the danger, or haha, here's the next lunch. And so,
and I think also worth keeping in mind too, the speed here. I mentioned this example somewhere, but I'm not sure which chapter it's in. But you think about anytime you've been in a car that's had an accident or gone into a slide on ice unexpectedly, and all of a sudden it seems like everything's moving slowly, except you can't make your muscles move any faster. But that the brain system is so efficient that it's recognized the threat, pumped you full of adrenaline, and all of that happens even before your conscious awareness is tracking the threat that your endocrine system is already responding to by giving you more and more adrenaline, which actually is why time seems to slow down. Is the adrenaline can speed up your thinking, and so it seems like things slow down because your thinking speeded up, but it doesn't really make your muscles move that much faster. It'll give you some extra strength, but doesn't give you that much extra speed. But cognitive speed it does give you, so you notice that. But so that's another part of the subtlety is that we're getting in all this information about the world, and then our emotional centers are reacting to it prior to conscious awareness, but with such speed that it seems as if all of those things can happen simultaneously. But there are in fact happening in an order in which the your unconscious mind is tracking things so much faster that it and is responding so quickly that your conscious mind can't keep up, and just is playing catch up after the fact to figure out what it is going on. So it's that again is sort of the idea that we've evolved to be these creatures where those cognitive functions can be really overwhelmed very suddenly with things that are really unexpected, or well, yeah, sort of out of the blue, you find yourself being totally disrupted. And so that's the argument, therefore, that we need these cultural functions at a deep level, so religion, that are going to help provide some mechanisms to know where to go with those things. And so it may not help all the time, but it'll help sometimes. And it won't help all people, but it'll help some people.
Is a level in which you have a way in which the entire process then is made conscious.
Oh, and also too, just so I'm clear, I think the same thing is true on a cognitive level with things that present to us as mysteries on it intellectually, that can be emotionally disruptive, and so you have the same kind of need to help you understand the world physically when it presents unexpected and startling things, as well as intellectually when it presents startling, unexpected things that you've thought about and suddenly are surprised by or disturbed by. It's like you need to be able to plug that into something to manage.
And enters your mind flow, even at this level, you can see that the influence on one's behavior is astounding. And it's by and large extremely useful. It has, of course, its downsides, because you may be responding to things that you better not respond to, either on the negative or positive side, and that you should not take the bait. You should not, for example, fall for every opportunity, and you should not allow yourself to be made angry, for example, or fearful, and there is no cause for it. But there is a way in which, by and large, the influence is very positive. And then the experiences of emotion also have a way of modeling what you're going to do next, because unlike, say, a squirrel, who is not going to think much about his or her experiences of emotion, we do. And we have, because we have feelings, because those feelings can actually stay in memory in terms of the elaborations that we make about the feelings, for example, using language, then we have a possibility of using feelings of certain emotions for future planning. And that makes a huge difference. So for a little animal that doesn't have much mind and no advanced planning, it's a way of keeping alive. For animals like us, it's a way of keeping alive sometimes, but an even better way of constructing a view of the world and making sure that that view is taken into consideration when we plan future events.
Okay. Stop there. Okay. Yeah. So, again, the thing that I think is really important here is this relationship he's getting at. That, so if we're the kind of creatures that have these feelings, and the feelings can be disruptive and linger and haunt us, then that's where the disruption comes. That I think that I'm arguing religion is there trying to offer us some answers, so that we can do something with those feelings that are otherwise might just be totally disruptive. So, sort of like feeling really small, looking up at the sky, that if you were spending all of your time ruminating on that and didn't know what to do with it, it could be very disruptive psychologically. But your worldview is going to come in there and give you some answers about what all of that is meaning and where you're fitting in there. And so then you might still be a little disturbed by the smallness of human beings, but you at least have a sense of what that is and why it's there, or how it's working. That the worldview is giving you how it works, and that gives you confidence to go on with it. So that's the idea, that kind of thing that I'm getting at. Any more questions at this point?
And Richard, did I read correctly that science kind of is an ideology itself that equates to religion?
Well,
that-
yeah, in that you can talk about I'm sorry, my dogs seem to be getting a little crazy here. There's probably a dog walking by. Hold on. Okay. Shh. No. Sorry about that. Uh-oh, I got distracted. You'll have to remind me.
Oh, that's okay.
Dog.
That science sort of
Worldview. Okay,
taken-
yeah. So yeah, one way to think of an ideology is as a very organized worldview that's suggesting responses to the worldview as well as an understanding of the world. And so yeah, at that level, you can talk about a scientific worldview, which so you have that's your overall overarching orientation towards understanding the world is going to be one about experimenting with it and drawing hypothetical conclusions and testing them and stuff like that. So, you know, and that certainly would contrast to someone who has a very overtly emotional kind of worldview that it's all about following their intuitions as opposed to testing those intuitions. Yeah, Bob.
It's got me thinking about spiritual practice.
Mhm.
And particularly, I've been into Buddhism a little bit lately. But having a spiritual practice kind of doesn't exactly armor you against being overwhelmed, but it does give you some abilities to either change your interpretation of how things are happening or be accepting of how things are happening, or give some perspective on being able to take things coming your way without going overboard as far as fear is concerned. And that's the real value to me of religious experience.
Yeah, exactly. Yeah, and I think when it's something you repeat, like a spiritual practice word implies, what you're doing in that repetition is you're strengthening those strands in that narrative web of yourself. And so I think that's the reason why those kinds of things work the way they do is precisely in the repetition that you make that pathway in your brain, that way of thinking, that way of navigating stronger and stronger and stronger through those repetitions. And you become better and better and better at maintaining equanimity when weird things come at you. And so, it's why you have novices and then you have practice before you get to be an expert it's all about it's in the power of that repetition.
Makes total sense to me.
Yeah, I think this is where Dennett, I running into Dennett, to me, it just made so much sense that model for thinking about what is a self and why, because you can use that to explain all kinds of things like this. Well, why does a meditative practice work the way it does? Well, it's because you're strengthening this narrative web. You're making it foundational to what is yourself. And so that's going to have a real consequence going forward. You're actually going to be stronger and able to handle disruptions, especially emotional disruptions, better and better as you do it. Janet?
So, or could it also be strengthening some brain connection?
Oh, well, definitely. It's doing that too. Yeah.
Yeah. So it's just repatterning that emotional response.
Yeah.
Not necessarily our consciousness about it, but.
Well, exactly that's so the metaphor is handy because the biology is pointing at the same thing, that the actual physical strands in your brain become stronger through repetition.
Yeah. See, that's that metaphor thing again. Who is talking about the autistic spectrum? Yeah. I have trouble with those.
And it's human beings really do love analogies and metaphors. It's something that philosophers have noticed sort of in literature, but it's disruptive to how we think about the world, because philosophers become famous when they have a really good metaphor. And the better the metaphor, the more famous they get. But when you start to break that down into a logical thing, it's like, well, but wait a second, maybe that's not really, is that the standard we're supposed to use? I thought we had these logical standards where it's about the logic of the argument, but it turns out, no, the most compelling arguments are the ones that have just the best analogies. But yeah, you take that to somebody with some autism and you're going to run into a wall. It's just not how their brains work. So what do? You got to have that little bit of synesthesia, a little magical synesthesia going on to have it work.
But then, Richard, there's also, right, a spectrum that, yeah, you know, extreme autism could be at one end, but,
Sure.
you know, I sometimes miss the point, you know, and I joke that I'm short, so it goes over my head.
We all have a little of that too. Right.
And some people are at the other end that are really good at metaphors. And I guess it's mostly, according to what they said, is more the artistic brain is better able to do that. So that could be at the other end.
Yeah, and indeed, spectrum is a good word to keep in mind, and that's why they use it when they talk about autism. You know, is that there's lots of varieties in there, and some can be much more dramatic, and some can be more subtle. And yeah, so these things are all working that way, little tiny, and because again, it's those little tiny details. You know, well, a couple of little neurons here or there get disrupted, or your genes don't form them right, or something, and all of a sudden you don't see faces. And it just seems like that's such an ordinary thing about just looking at the world. You're just looking at circles and triangles and squares and stuff, and you put it, but it turns out it's actually a special talent that you evolved in your little primate brain to be able to do.
So it's amazing that we function as we do, that with all the things that could possibly go wrong, it's amazing how often it goes right.
Yeah, I think that's true. I think that's true. We notice the going wrong. We talk about the going wrong a lot, but right, when you actually step back and look at the world, most of the time, most people in the world are doing ordinary, normal things, behaving like decent people, and that's just what they do. And yeah, and it's
and at work, we would say the opportunity for errors, and certainly the human body has millions of opportunities for errors.
Right. And those little neuron errors too. Okay. All right, almost 1 o'clock. So I'll let you go here. Hopefully you're having a little fun and starting to see what I'm talking about, how our brains work, and that really helps us understand religion.
Thank you.
All righty. Well, thank you all. So again, no class next week. I can't really figure out how I'm going to make that work with my time zone and vacation. So we'll just skip next week. So we'll go back here. The thing I want to get to finishing in chapter 3 is kind of the more application side, which is the conversation I had about Friedrich Schleiermacher, which is how that you say that long name that starts with an S. Interesting guy, because he really did seem to be kind of ahead of his time in the way that he was looking at the role of feelings in all of this. Okay, so that'll be 2 weeks from today, and I'll send out a reminder next Wednesday so you all know that we're reminded that we're skipping class. And in the video too, I'll send out the video later today.
And then also, could you keep us in track, Richard, for what chapter we should be?
Yeah, so it'll be
okay.
We'll finish chapter 3, and probably that will take all day.
Okay.
All class period in 2 weeks, and then we'll go on to chapter 4.
Okay. Thank you.
Okay.
Thanks.
Thank you all. See you later.
Thank you.
Enjoy your vacation.
Thank you.
Yes.